Hi, okay, welcome to the Turning Effect of Forces Assignment 3. Okay, this is a relatively short and simple assignment. All right, the main focus is on the center of gravity. Okay, so it is a small part of the topic, but nevertheless an important part because the position of the CG will help us determine whether or not an object is stable or not. Okay, at the same time, it can also help us solve questions related to moments. Okay, so for question 1a, they ask you to state the meaning of the center of gravity. Okay, so same thing, this can be found inside your notes. All right, I'm not going to talk too much about this, but I'm going to tell you that the main focus is actually a point. All right, and a point where the weight seems to act on. All right, the word seems over here, okay, means that of course, in reality, okay, weight acts on every part of an object as long as there is mass, okay. But because all the mass, when they come as one single object, all right, we can actually, find a kind of averaged point where the weight is actually acting on. It's as if, let's say, the object is only of a point mass, a single point. This is the point where the weight is acting on. Okay, so it's a bit abstract here, all right, but nevertheless we need to use the word seems. Okay, it is not a point where, all right, the weight is acting on. Okay, and now take note on one thing about the center of gravity, that is CG can be a point that is lying outside the body. All right, it does not have to be lying within the body itself. Okay, so this is another abstract part of this definition. Okay, state two conditions for stability. All right, two conditions for stability, meaning to say for an object to be stable. All right, they're not asking for two factors, all right, of stability. Okay, they're asking for two conditions, so something that must be satisfied. Okay, so one, I must have a large base. The other is I must have a low CG. Okay, these are the two conditions, all right, for an object to be stable. So for question 2, all right, we have 4 examples of stating whether, to state and explain whether the shown object is stable, neutral, or in an unstable equilibrium. Okay, so we quickly talk about stable and unstable. It's very simple. Stable means if displaced, means you move it slightly, it can go back to original. Unstable means if you move it slightly, all right, it will not go back to original. Neutral is something that, the CG doesn't move. All right, so later on we look at one example. So for A, state whether is this stable or unstable. So you see the CG, this is the pivot. As long as the CG stays within the base, all right, it is always stable. All right, because it will create in this position, in this particular case, it creates an anti-clockwise moment. Okay, it creates an anti-clockwise moment that will actually put your box back to its position again. So this is going back. All right, so this is stable. Explain. Okay, the CG lies within the base of the box. All right, very simple. Of course, if you want to go one step further and explain that, the CG will create a anti-clockwise moment that will restore the box back to its original position. Okay, that is perfect. All right, just go ahead and write that. Okay, the part B state this is basically an example of neutral. So you see, this is the CG, right? So no matter how I roll here or roll there, all right, the CG will always remain on the same position, right? So CG remains on the same line. Okay, so that's the definition of being neutral. So for this example, you see the CG is being raised up a lot higher. So you see now the CG actually creates a moment that is now, we call it the clockwise moment. All right, so if I'm going to release the box will likely fall on its side and not go back to its original position. So this is what we call unstable equilibrium. Okay, So explain, we just say that the CG lies outside its base. What's the base? The base is here. Alright, so it lies outside the base, so it will not go back to its original position. Okay, alternatively, you can say that the CG exerts a moment or creates a moment. What moment? A clockwise moment that will topple the box. Okay, so that's unstable. So a lot actually chose for part D, a lot actually still choose neutral, a lot. All right, no idea why. Neutral, it basically means that the CG will not move. So I want to pose this question again. All right, the ball, once it rolls down, here or here, will the ball ever come up to the top of this hump again on its own? All right, likelihood is no, unless a third party force, okay, somebody actually picks up the ball and put it back there. Okay, on its own, it will not go back, it will not be restored back to its original position. So this is what we call unstable. Okay, so why? All right, the CG, in this case, we explain using the CG. All right, so CG, okay, will drop, okay, and not go back to its original position or original position. Okay. Question 3. Figure shows two empty garden pots A and B. State and explain which pot is more stable. So give two reasons for the answer. So the more stable pot is, I think a lot of you already know the answer is B. Okay. Reason number 1. I think the most obvious one is B has a larger, oh my spelling, a larger base than A. Always remember to make comparison. Don't ever just say B has a large base. Okay, because you are comparing A and B. You give your answer in terms of comparison. Large or small is always relative. Okay, we want to compare. Reason 2, so this may not seem as natural or logical, okay, to some. Okay, so this reason 2 is we want to find the CG. So B is relatively, how do I say, homogeneous, right? It's like a rectangle, except for the top part a little. So I'm just going to assume that the CG is right in the center. Okay, CG will always follow where the mass goes to, meaning to say wherever is heavier, CG will tend to move towards that direction. Okay, wherever is heavier, CG will tend to move towards that same direction. So pot A, you see, bottom small, top big. So logically speaking, do you think the top is heavier or the bottom is heavier? All right, the top is heavier. So let's assume, all right, geometrical center is, not say geometrical center, the center is here, all right? But because the top is heavier, so what happens is the CG will actually move up higher. All right, CG will always move towards where the weight goes to. Okay, so in this case, we also say B has a lower CG than A. These are the two reasons. Okay. 4. The stability of a lorry is tested as shown in the figure. So the ram is tilted as much as possible without the lorry falling over. The ram is then fixed and the lorry remains at rest in this position. For what? Not sure. Maybe to test. All right, before they commission a particular design of a lorry, they probably want to test, what is the maximum angle that the lorry can go. All right, so usually this is some kind of a safety kind of a test. So on the figure above, draw 3 arrows to represent the forces acting on the lorry and label the arrows with the names of the forces. Okay, I think the easiest is what? CG is here, so of course I have the weight label, all right? Then you see this, the lorry does not slide down, right? Why does the lorry not slide down? Okay, because there's this thing called the friction. And what is the friction acting? Friction has to be acting against the direction of the sliding, right? So this is friction. So they only want 3 arrows. So technically speaking, we also should have a friction over here, right? But okay, we don't need it in this case. So we only need 3 arrows. So we just give the general direction. Another one is what? Another arrow. Okay, so there's, of course, according to Newton's third law, there is this thing called the reaction force, right? So over here, the point of contact, boom, Again, we only need one, so reaction force or normal reaction. Okay. All right. So these are the three forces. Okay. Any others? I don't think there are anymore. Okay. So explain why the lorry falls over if the ram is tilted any further. So you see, the CG is now the weight is now acting within the base, so it does not fall over. But imagine if I'm going to tilt some more, the CG will be moved to the right a little more, such that the CG will fall outside the pivot. This is the pivot. This is the pivot. Let me draw in red. Draw in red. This is the pivot. Okay. So if I am going to tilt any further, the CG will most likely fall out of the pivot. So if it falls out of pivot, it will actually create a moment. What moment? A clockwise moment. All right, that will topple the lorry over. Okay, so how we're going to explain? We just tell them that if tilted further, what happens? The CG will fall out of its base. This is one mark. The second mark, so what if it is out of its base? All right, the clockwise moment, okay, generated, my spelling, generated will cause the lorry to topple, all right, to its sides. Okay, so that's the second mark. C, state how the position of the center of gravity affects the stability of the lorry. So this is a relationship question, okay? How the position of the CG. The lower the CG, comma, the more stable the lorry, okay? You can also explain it in terms of, state the relationship from the other angle. All right, the higher the CG, the less stable the lorry, okay? And okay, that is it for this assignment.